Hello everyone. Welcome to one of the most exciting parts of our OpenStudio tutorial series. So far, we've built a simple building model together. We have drawn the geometry, defined materials and constructions, thermal zones, and added the weather file. Now it's time to see how this model actually performs under real-world conditions. In this video, we'll run our first simulation, explore the EnergyPlus outputs, and use the powerful DView tool to visually analyze the results. We'll see how our building behaves without any heating or cooling systems, how it responds to outdoor temperature changes, and the impact of thermal mass. If you're ready to see your model come to life, let's get started. You're this close to running your first simulation, but let's make sure we get detailed, actionable data out of it. Before we hit run, we need to tell OpenStudio exactly what to record at every time step. Click the Variables tab on the left sidebar. This is your output control center. Here you request time series data from EnergyPlus. Use the search bar at the top to quickly find what you need. Just type temperature. Now turn on these 4 key outputs by toggling the request button to on. Surface inside face temperature, surface outside face temperature, zone air temperature, zone outdoor air dry bulb temperature. Click the request toggle to turn it on. Then change the reporting frequency from hourly to time step. This captures data at every simulation time step, usually 6 to 15 minutes, instead of just once per hour. Do this for all 4 variables, just like shown on screen. Why time step? Because we want to see fine-grained behavior, how quickly walls heat up, how the indoor air responds to solar gains, and how outdoor temperature swings affect the building. Hourly data obscures too much detail, making it harder to learn and debug. Your model is complete, outputs are configured, and OpenStudio is ready to simulate. Let's run it. Click the Run tab on the left-hand sidebar. Press the big Run Simulation button at the top. Sit back and watch the real-time output scroll by. You'll see weather data loading, surfaces being processed, and systems being simulated. Now click the Results Summary tab. In the upper left drop-down, you'll see 2 default reports, OpenStudio Results and EnergyPlus Results. Select OpenStudio Results. This is the clean, user-friendly summary we want. Since this chapter is all about the building envelope, scroll down or click the Envelope Summary section heading. Here's what you'll find: total exterior wall and roof area, window-to-wall ratio, list of constructions applied to some surface types, U values and R values, etc. Now let's dive into the zone conditions section of the OpenStudio results report. This is where we see how livable our building really is. Look at thermal zone 1. Over 1800 hours spent above 88 degrees Fahrenheit. That's scorching hot. Nearly 1700 hours between 83 to 88 degrees Fahrenheit. Still really warm. Only 40 hours below 68 degrees Fahrenheit. Almost no cool periods. Mean annual temperature, 81.6 degrees Fahrenheit. Way too hot for comfort. In humidity breakdown, over 8,500 hours, nearly the entire year, at below 30% relative humidity, extremely dry. Mean relative humidity, 22.6%. Desert level dryness. These numbers indicate that, without any HVAC, our tiny unconditioned building is uncomfortable for nearly 100% of the year. Either too hot, too dry, or both. This real simulation data proves exactly why we install mechanical systems. To cool in summer, to heat in winter, to control humidity year-round. In the upcoming chapters, we'll add thermostats, HVAC systems, and ventilation, and dehumidification. This is the power of energy modeling, seeing discomfort before construction, then designing it away. Now that we've seen the OpenStudio results, let's look at the raw output from EnergyPlus. At the top of the Reports tab, use the drop-down to switch to EnergyPlus Results. This is the detailed report made by EnergyPlus. It's great when you need more technical information. Let's check the project folder. OpenStudio saves your model and builds a full simulation folder. Go to your model folder. Inside, you'll see a Files folder with the Weather EPW file, a Reports folder with 2 HTML files, and a Run folder. Open the Run folder. Here are the key files. in.osm, the final OpenStudio model before simulation. in.idf, the EnergyPlus input file. eplusout.err, warnings and errors for troubleshooting. EPlusOut.SQL, the time series database for graphs. Always check EPlusOut.ERR first if something looks wrong. Use EPlusOut.SQL with software like DView for custom plots. The EPlusOut.SQL file is our gateway to the final step of this first simulation, exploring time series results. EnergyPlus creates huge sets of data. It includes standard outputs plus the variables we turned on in OpenStudio. All this data is saved in a SQLite database. The SQL file. This saves space and makes loading faster compared with the text file. DView is a free tool made just for studying this data. It opens the EPlusOut.SQL file directly. You can open it two ways, manually in DView, or click the Open in DView button in the top right of the Reports tab in OpenStudio. If you don't have DView, you'll see a button that says Set Path to DView in Preferences. Here's what to do. Go to this link, download the latest version for your system, Windows, Mac, or Linux. Extract the file on your computer. In OpenStudio, go to Preferences, Configure External Tools. Browse to the DView file inside the extracted folder. Click Open, then OK. You should now see the Open in DView button in the top right of the Reports tab. Click it, and DView will launch with your simulation data ready to explore. Alright, let's take a closer look at the outputs in DView. Right now, I'm comparing the outdoor dry bulb temperature with the zone temperature for our model, using the finest time resolution available. As you can see, a few key observations jump out right away. First, the interior space temperature lags behind the outdoor temperature trends by about an hour. That's the effect of thermal mass in action. Second, the indoor temperature curve is much smoother. The building's materials are damping those sharp outdoor swings thanks to their thermal capacitance. Third, you'll notice indoor temperatures staying higher than outdoor. That's solar radiation pouring in through the south-facing windows, warming up the space. And fourth, well, let's be honest, this building would be pretty uncomfortable to spend time in without any HVAC. DView gives us plenty of other ways to dig into the results. For example, let's check out surface temperatures on the south-facing facade. Over in the Geometry tab previewer, rotate the model until you spot the south wall. OpenStudio has automatically named it Phase 4. Once we know the surface name, we can head back to DView and select variables tied to Phase 4. Here, I'm showing the exterior surface temperature as a heat map, a color-coded view by month and hour of day. It's perfect for quickly spotting those peak hotspots, like scorching summer afternoons on the south wall. And in this view, we have monthly profiles averaging the exterior and interior surface temperatures hour by hour across each month. Both of these visualizations are great for picking up seasonal patterns or catching anything unusual in this simulation. Keep exploring DView on your own. You'll start building a strong feel for how your building behaves under real weather conditions.